This Monday, November 26, around noon Pacific time, NASA will attempt to land a spacecraft called InSight on Mars. While a lot of previous missions have looked for life, evidence of past life, water, liquid water, and so on, this is the first mission dedicated to studying the interior of Mars. InSight will do that from one location. There is no rover, so wherever it touches down is where the science will happen. Now, InSight stands for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport. So let's go through each of these aspects of the mission and discuss the many firsts that will be attempted. InSight is the first Mars mission to use a robotic arm to grasp and place instruments directly on the surface of Mars. Sure, some rovers in the past have rolled off their base and onto Martian soil, but this is the first time we're essentially playing the claw game on the surface of another planet. Without real-time feedback, of course, because of the long time delays. Now, one of the instruments that will be placed on the surface will be the first seismometer actually on Martian soil. The Viking landers from the 1970s had seismometers on board, but because they weren't placed directly on the surface of Mars, they essentially just measured the wind blowing over the lander. The seismometer will detect earthquakes, or actually Mars quakes, and landslides and meteorite impacts. Now, do we expect there to be many Mars quakes? Well, we really don't know. Otherwise, what would be the point of the experiment? This is directly relevant to future human exploration of Mars, because the frequency and intensity of Mars quakes will determine how we build our structures and habitats. But the real goal here will be to use any significant ground motion to figure out what the interior of Mars is like. Like, how big is its core? Is it solid or liquid? It'll be kind of like trying to figure out the shape and composition of a bell by listening to its ring. Seismic waves travel at different velocities depending on the density, composition, and state of the material they're traveling through. The seismometer should be able to detect ground motions smaller than the diameter of a hydrogen atom. They're achieving this with 3 tiny precision pendulums. Now, I don't know how that's actually possible, so I'm just taking their word for it. But with such exquisite sensitivity, they've designed a custom windshield to go over the whole thing, preventing the atmosphere from adding noise to the measurements. Another instrument will send radio waves back to Earth, and by using the Doppler effect, we should be able to measure how Mars's rotation axis is wobbling. This will provide more insight into the actual structure of the planet. Think about how a raw egg spins compared to a hard-boiled one. The more wobble we observe, the more liquid there is inside. And by combining these observations with the seismographic data, we should be able to figure out the size of Mars' core, what it's made of, and whether it's liquid or solid, the thickness and the structure of the crust, and the structure of the mantle and what it's made of. Another first? Figuring out how much heat is escaping Mars' interior. The first heat probe to be used on Mars will be deployed on its surface, and it will burrow nearly 5 meters down into the planet. This is the deepest we have ever dug on any planet besides Earth. In fact, it'll take around 3 months to dig that far. The probe is attached to a tether which has 14 temperature sensors along its length to measure the thermal gradient beneath the surface. And it can only dig into soil. If it hits rock, we're in trouble. This instrument also has heaters on it, so it can warm the ground around it and see how long it takes for that heat to reach the other temperature sensors. Finally, InSight will be the first to use a magnetometer on the surface of Mars. Mars long ago lost its global magnetic field, but there are still magnetic effects to be measured. As the solar wind strikes Mars' upper atmosphere, it creates moving ions that produce magnetic fields. And the likely metallic core of Mars is proposed to interact with these magnetic fields, which will be measured on Mars' surface. So the magnetometer provides further insight into the nature of Mars' core. So what is the whole point of this mission? Well, this is straight up science. The purpose is to better understand how rocky planets like our own form and evolve. And Mars offers a unique opportunity to do this because it formed at the same time as Earth from roughly the same stuff. Plus, it's big enough that it probably underwent the same geochemical changes as Earth. But whereas Earth evolved into a lush water world, Mars evolved into a frozen desert. So why is that? I mean, beyond the obvious size difference and different distance to the sun. Perhaps InSight can help us find out. But first, it has to land on Mars, and since less than half of missions to Mars have landed successfully, that's a big question mark. And if you want, you can tune in and watch the landing live, though we'll only know about 4 minutes after touchdown if it made it or not. I'll put a link to that in the description. For me, I feel like this is a great mission to understand some fundamental science about planets and their formation. And unlike other missions that go to Mars and have to claim some sort of profound life implications, this is about fundamental science and how planets work, which I think is really cool, and I'm looking forward to the results.